Because when it comes to net zero transition, it's not just one country. The entire world needs to come together. So yeah, so whilst we can make a lot of progress in the UK, we can't forget that many other countries exist.
Hello and welcome back to the Hypercube podcast. Exciting one today. I am joined by both Gus and Sheng from the Centre for Net Zero. Good morning, chaps. Would you like to first, introduce yourselves for the audience at home?
Yep, sure. So, hi Adam, I'm Gus. I'm the data lead at Centre for Net Zero. Yep, joined in July 2023, I think. The goal of managing the data team and overseeing our data and modeling projects that we work on. Before that, I've had various kind of roles, mainly data focused, but in different industries. I started in finance and then marketing, had my own little startup journey and then came here.
Cool. Yeah, my name is Sheng. I'm a senior data scientist at Centre for Net Zero. I joined CNZ, I think in June 2022. And predominantly been working on generating synthetic smart meter data. And prior to CNZ, I've worked across many different industries, mostly in the tech startup and scale-up world. Started off in finance, like Gus, and worked at Cloud and Monzo before moving to e-commerce, and then working on recommendation engines at Gusto, and now working on generative AI stuff at Centre for Net Zero.
Really exciting. Yeah, could talk about smart meter data all day, actually. But before we get into that, it'd be just interesting for those in the audience that maybe don't know the Centre for Net Zero or aren't deeply aware. Could you give us a kind of run through of why it exists, what you're trying to achieve, like some of the main outcomes and deliverables?
Sure, yeah. So Centre for Net Zero is a not-for-profit, impact-driven energy research institute, which was founded by Octopus Energy Group. It's one of the largest energy retailers in the UK. But as an institute, we operate autonomously, designing and running research and field trials all around the world to kind of generate data and insight about the future energy systems. So we're a team of, I think, 18 now, made up of data scientists, economists, strategists, and policy experts. And our goal is to kind of accelerate the journey to a fully sustainable global energy system. In terms of the problems we're trying to solve, so obviously our energy system is changing rapidly, and we're looking to decarbonize, introduce new technologies. And we think understanding consumer behavior is essential to this transition. One of the things we're working on is the data. So kind of a lot of the critical decisions today in energy use data from the past, and sometimes aggregated out of date data, mainly due to privacy or technical concerns. Few organizations have kind of open access to the right energy demand data like us, or the motivation to share it. So we're kind of working to make this data open and use it to figure out how to do accurate kind of future demand prediction. So we at Centre for Net Zero, we've kind of got the access to the data, access to the consumers to understand their behavior, and that kind of combination will allow us to hopefully kind of really understand demand in the future. So that's what we're trying to do. And Octopus obviously is growing as well. We're going global, and our research is going to kind of go global with it, ideally. So that's us. Hope that gives a bit of an introduction.
That's really interesting, and it's good to hear there's a mix of economists and it's not just all techies, or it's not just all sort of energy people. I guess just wanted to sort of lean into the question a bit. How do you prioritize what to go after? Because it's such a huge remit, right? How much of it is driven by the economics and the forward looking, the big change stuff versus like technology driven? Like, are you like you talked about generative AI in the introduction? How much are you saying, well, actually, there's an opportunity here, and we need to be the people to do the kind of TRL 1, 2, 3 part of that journey?
Yeah, great question. I think, yeah, two main things to point out. One, we've got to play to our strengths, and that is the relationship that we have with the wider group and the access to the customer data. So we have to really, leverage that data and those customers and make sure our research is fully aligned to that. I think the second one is, we're one of our missions is to do really impactful stuff that no one else is doing. So we probably were trying to do more of the kind of future-looking scenario-based stuff rather than the day-to-day operations, because that's where we see the biggest chance of making an impactful change.
Yeah, and to add to what guys are saying as well, because a lot of the data that we have right now are data from the past, but we all full well know that in the future, with climate change and with technology adoption, today's data is not going to be reflective of what's going to happen in, say, 10, 20, 30 years' time. So I think what we're really trying to do is like thinking about how might the world look like in the future, and then actually carrying out trials today to kind of collect data that's reflective of the world that we may see in the future, and then taking some of the data that we've collected with trials and then doing some modeling and actually see, how could we make net zero a reality. So I think that's kind of like what we really can do at the sense of net zero, apart from that's quite different to many other research institutions out there.
I mean, that's really interesting. Like last week, I was in with another major energy provider, not the Octopus Group, but of that scale, talking about exactly this smart meter data, and it was mainly around decarbonisation of heat. And just like, where do you even start? Because you've got like building physics models, you've got like retrofit schemes going on, even having access to the data actually is really difficult unless you're one of these scale organizations. I guess it puts you in a really useful position, like even just the interface and owning all the gubbins that you need to support DCC queries and so on and so forth. Like, it's no mean feat. Yeah, where do you even sort of start on that modeling, like that models of models kind of journey?
Yeah. Well, I'll let Sheng go into synthetic data a bit more and what its kind of advantages are. But that's been our main angle. So creating really realistic synthetic smart meter data. But on your point for kind of openness and democratization, one of the things we identified really early on is that we want as many researchers and commercial organizations and PhD students to have access to this data as possible. So earlier this year we launched like an open community around synthetic smart meter data called OpenSynth, partnered with Linux Foundation Energy. And the goal of that really is so that they're just like accelerating the amount of smart meter data in circulation. So not only are we kind of driving our own research forward, we're allowing other people to do that as well. And the community's been really kind of successful so far. We've released some synthetic smart meter data, and we have other people really interested in doing the same. And so yeah, it's been a good journey so far.
We had someone from the North Sea Transition Authority on about 6 months ago now on the podcast, and just similar parallels in that they became the people that owned all the seismic data for the North Sea and did a great job of opening it up to researchers and like other organizations. And then the pace of like research, innovation, like new understanding and people being able to get access and get involved with it has like orders of magnitude change. So a really noble effort and really interesting, but like, yeah, not possible without synthetic data if you're dealing with people's homes and energy usage, right? Like, tell us a bit more about that journey.
Yeah, I think at the start when CNZ first started, I think in 2021, CNZ was partnering quite a few different researchers, and it was quite difficult to actually share data with the research community because with every partnership that we do, you need to have a separate legal procedure, and then you need to do all the engineering steps to clean the data and make sure it's anonymized. And then anonymization is also not foolproof. There has been quite a few instances in the past where people were able to reverse engineer anonymization or aggregation to get back to the raw data. But there was still like lots of risks involved in that. And obviously, when it comes to smart meter data, lots of people are quite sensitive about it. So then at Center of Net Zero, we just thought, how can we make this process of sharing data in a more scalable way, and also, in a more scalable way, and also looked at privacy as something that we want to consider, because obviously many people are quite sensitive about it. So we then started looking at generating synthetic smart metadata using generative AI. And then we put something out there in 2022 when lots of people are quite interested. And to date now, we've got like just over 100 alpha users for our tool called Faraday. Yeah, so we've got researchers from Oxford, Birmingham, Manchester, Cambridge using Faraday. We've also got German business have used Faraday in some of their pieces of work. So yeah, we've got people from consultants, researchers to government and regulators using Faraday. And then we thought, because obviously Faraday is trained on Octopus households in the UK, and the world doesn't just revolve around the UK. There's many other people in many different countries, and then all of them are looking at, also crying out for data. So we thought, how do we accelerate this progress that we've done on this front? And then we thought, how about let's set up an OpenSynth, which is the open source community with Linux Energy Foundation, and hopefully we can accelerate generation of granular energy demand data, not just in the UK, but globally as well. So that, because when it comes to net zero transition, it's not just one country, the entire world needs to come together. So whilst we can make a lot of progress in the UK, we can't forget that many other countries exist and need to get more data, and that's how we set up OpenSynth to really accelerate the efforts there.
So I imagine like the data that you'll get from meters across other countries aren't going to, like, it's just not going to meet the same standards and the same sort of granularity, like different sort of sampling frequency, so on and so forth. So is that posed a challenge yet, or are you thinking about, is there like an abstract data model that is like smart meters that applies everywhere?
Yeah, so that's something that we're not really that worried about, because maybe different countries might have different sampling methods. I think in California it might be down to like every 15 minutes, and then I think some European countries also at 15 minutes, whereas UK is at 30 minutes. But I think it doesn't really matter, because it depends on the granularity and what you want to look at. Because in the UK, the most granular gets at 30-minute intervals. So any research to the UK will be at that interval. But if you're at other countries, I think you could generate a 15-minute interval, and then you can aggregate it up to 30 minutes. It's really up to the people holding the smart meter data what they want to do with it. So I think it's more of the behavior, getting a wide representative behavior of how the world uses energy that we care about. Because obviously not everyone's going to use energy the same way that UK citizens are using, either because of behavioral stuff or because of weather-driven consumption behaviors. One, obviously, like, people in Texas would be using energy in a very different way to people in the UK because of climate. And then it's about getting a representative data set of the world that we live in. And then we can then look at how we might be able to model consumption in one country, and then how the entire world can function together. As agreed, like recently, UK, we started investing sort of in Morocco, which is like a couple of hours behind in the UK, so that whilst the sun is shining in Morocco, energy can be, solar energy can be used to meet the demands of UK evening peak times. And you can only really do this if you look at globally how different people are using energy in different ways, and how then we can all come together. And it's about the global representativeness of the data set that I think is more of a challenge. That's the thing we're trying to prioritize it, actually.
That's kind of the main purpose of the community. So it's to bring together those different holders of disparate raw data, the different methods to then generate synthetic data from them, and the different use cases people wanted to use that data in their research, have them all in kind of one big mixing pot so that people can, have one place to find what they need. Yeah, no one size fits all model, unfortunately, but hopefully, one community to kind of hold it all, basically.
No, that makes sense. And while we're on the topic, then, any sort of tech specifics and that are really interesting, or like in generating synthetic data, what kind of tech stack are we using, and what are there any like surprising finds in the technology, or is it just trying to keep pace with like OpenAI and whoever else?
I think one of the things that we looked quite closely is on topic of privacy, because the whole point of us trying to create synthetic data is to make sure that the privacy of your original data set, or basically people's energy consumption, is actually being preserved. And how would you actually know that your data is genuinely synthetic and not actually just regurgitating the original training data, because it's doing that, and that kind of defeats the whole purpose of synthetic data. And when we were doing literature review of like how to generate and evaluate synthetic data, and we also found that there are lots of papers on how you could do it, but many people are also evaluating it in their own ways. There is no common standardized benchmark, so that it's really hard to compare algorithm 1 to algorithm 2. And most importantly as well, privacy is also not a topic that many people talk about, and how are they actually going about in evaluating privacy. But actually, on the topic of privacy, there is actually already a lot of research done outside of energy. For example, in healthcare, lots of researchers are looking at synthetic healthcare data sets and how to protect privacy in those data sets. And recently, Net Zero, we released a paper called Defining Good, basically evaluation frameworks for synthetic smart meter data, where we look at things like fidelity, utility, and privacy, and looking at, how do we actually evaluate synthetic data is really private, or actually just spitting out training data. Yeah, and I think that's basically, the biggest challenge about synthetic data is, can we actually generate synthetic data that is, one, highly private, but two, still remain useful, because the more private it is and the less accurate it is, and what is that trade-off we're talking about when it's coming? Yeah, when they're trying to trade off between privacy and the usefulness of the data set.
And do you find that it's still quite like an immature part of the kind of tech space? Because the reason I ask that is from our conversations with a lot of customers and big other organizations, but also their customers, people aren't as protective or as nervous about this smart meter data until you highlight the value in it to them, as they would be with their finance, right? And a lot of the work I've seen in synthetic data is around like financial transactions, and organizations like the startup Hazy that's really exciting, doing cool things with like fraud detection. Do you find that it's still quite early days in that space?
I think it depends. I think with the thing that with privacy is, you never know the damage until it occurs. So sometimes it might be more responsible, better to have things upfront to protect them, rather than wait till bad things happen and then everyone panics, and then that's then going to set progress 10 steps backwards. And sometimes it's much better to be proactive about it. And there are lots of examples of how things like this happen. Like, I think when I was doing my postgraduate in machine learning, one of the classic examples that was taught in textbook was, there was once where a supermarket was sending marketing emails to people's mailboxes, and they started sending pregnancy or baby related to a household with a teenage daughter. And then the parents was like, what's going on? And turns out that teenage daughter was pregnant, and I was looking at pregnancy kits, and then that supermarket found out I started sending things like this, and then that became an ethical issue. And with privacy, that's exactly the type of things that we're trying to prevent upfront, and looking at and have means to actually quantify privacy and look at how to protect it. And we don't want negative things to happen, because the probability of negative things happening is small, but the impact, especially impacts individual, could be quite big. For example, if we manage to reverse engineer smart metadata and identify that this smart metadata belongs to you, and then identify that, oh, you were doing some behavior at this time of the day, and suddenly you're not, something might be going on, and it could cause unintended consequences on the individuals. And even in the UK, there is quite a high resistance as well to smart meter adoption compared to many other countries worldwide. And negative impacts like this is just going to set the progress of energy digitization backwards. And personally, I think it's much more responsible when we're dealing with data to be thinking about this and be more proactive about it rather than just wait for things to break and then try to fix them. And sometimes, while they try to fix them, it should have been done. But yeah.
I think it's quite hard for people to understand how organizations like us can use the smart meter data for such like amazing benefits. One of the things we're going to be working on later this year is to try and identify some of those use cases, so that, and maybe kind of publish some of the most important ones so that people can potentially link to it and then build that trust that we're using the data in the right way to drive real change, and it's not, for commercial reasons, for example, or anything else. So we think building up that link will be key to getting a bit more trust in synthetic smart meter data and kind of allaying some of those fears.
I guess you mentioned like forward looking and some of the research challenges. Do you have any insight into what you think the next steps for research or implementation of this are going to be? Is there anything to kind of lead the audience?
I think there are lots of new models and algorithms coming out to generate synthetic smart metadata. One of the drawbacks with the algorithm we had is right now we are only outputting daily profiles. Part of the reason is because of privacy reasons. Other reasons could be, it's also due to like computational reasons. I mean, there are new algorithms coming out, specifically things like diffusion, where it really blew up last year when I think you have a new company called Stability AI with their diffusion models and using the diffusion algorithm to generate synthetic images and videos. And right now, there are quite a few papers coming out about using diffusion as well to generate very long-range time series. So that could be a potential technology that might be of interest that we want to look at. And also, I think we need to understand, come up with more research actually to look at and evaluating synthetic smart metadata, because I think lots of skepticism when it comes to synthetic smart metadata is, are they actually accurate? Can we actually really use them in place of real data? Having more research on that, say, we compare real versus synthetic data in this use case and that use case, and that would just give more evidence that yes, synthetic data could be a very quick way to democratize data for research and modeling purposes and other stuff without having to share the real data, and it's just much quicker and easier. More research in that front, I think, will hopefully increase the adoption and lower the barrier to adopting this technology.
Well, it's been a really interesting conversation. Thank you very much. I always just like to ask if the audience would like to find out more, or if you've got anything you'd like to plug or promote, now's the time. Where should we be sending them?
Yeah, sure. So our website is centrefornetzero.org, and you can find all of our output on there, our papers, our tools, our thought pieces. We're also kind of on the socials, LinkedIn and X, and search for Centre for Net Zero. The papers Sheng mentioned are linked from our website, and details about OpenSynth, the synthetic data community, also you can find on our website. That has a mailing list where we kind of reach out with new data sets or updates to the community and the algorithms. So yeah, centrefornetzero.org is the main place.
Amazing. Well, thank you very much. I've really enjoyed it. All the best at Centre for Net Zero. I'll be checking out the newsletters and things because it's very pertinent to some of the stuff we're up to. So great conversation. Thank you.
Cool. Thanks for the chat, Adam.